Okay, now let's talk about YouTube. YouTube is a simple instrument which is used for calculating pressure of trapped gases. Trapped gases mean the gases which are located in some container. How do we calculate pressure of those gases? We use simple instrument called U-tube, a tube of U shape. Okay. Now let's see how do we calculate the pressure of trapped gases. Okay. These are the examples. Let's see how do we calculate the pressure. Here, both ends of the U-tube is open to air. It means air can apply pressure here. Now, pressure at this point and pressure at this point, they are equal. P1 is equal to P2 equal to air pressure. On this point, pressure on this point is equal to pressure on this point. It means P1, P2, they are equal. Let's see this diagram. Here we have three different liquids. Liquid number 1, 2, and 3. For the calculation of pressure, we just choose one level and we calculate pressure on that level. For example, we can choose this level. On this level, what will be the pressure? And pressure on this point is equal to pressure on this point. Pressure on this point, how many pressures do we have? One, pressure of this third liquid. Next, pressure of air. Air also applies pressure. So two pressures here we have. And on this point, pressure of this liquid plus pressure of this liquid and air pressure. Now, let's calculate pressure on these 2 points. Pressure on this point, pressure of third liquid. We represent pressure of third liquid by P3. P3 is equal plus another pressure here we have P0 equal to. On this level, pressure of first liquid means P1 plus pressure of second liquid means P2 plus this pressure, air pressure. Air pressure, we can cancel them. Now, pressure of third liquid is equal to pressure of first liquid plus pressure of second liquid. Okay, let's see some example related to this topic. This example. What is the density of the first liquid? Where is first liquid? This is first liquid. How do we get first liquid? From this number. Each one is part of first liquid. We have to calculate density of this liquid. Here we have to choose one level. And we can choose this level. Let's choose this level. And calculate pressure on this level. Pressure at this point and at this point, they are equal. So let's calculate pressure on this point. Here one we have air pressure. So P0 plus. Second we have pressure of this liquid. Liquid number 2. P2 equal to. This side finished. Now let's take this side. P0 here we have plus pressure of this liquid number 1. Pressure of liquid number 1. P0, we can cancel them. So P2 is equal to P1. Liquid pressure, previously we had discussed. Liquid pressure is density times gravitational field times H. But this is the density of second liquid because we are talking about pressure of second liquid. So D2 height is also height of second liquid equal to density of first liquid times gravitational field times height of first liquid. Now we just plug the values, the given values. Density of second liquid here is given 2 gram by centimeter cube. Density is 2 gram by centimeter cube times G, they are 10, 10 cancel. Let's here simplify the equation. They are cancel. Next, height of second liquid is 5 centimeter. Equal to density of first liquid, we don't know, we have to calculate d1 times height of first liquid is 20 centimeter. 20 centimeter. Now here we have 10 gram by centimeter cube times centimeter equal to 20 centimeter times d1. Both sides we divide by 20. So 10 divided by 20 will be 1 by 2. It means 0.5 gram by centimeter cube is equal to d1. This is the density of first liquid. And let's continue. Okay. YouTube here, YouTube is connected to trapped gas. Here, and YouTube is connected to trapped gas. And here we have liquid. This liquid commonly will be mercury. Commonly we use here mercury for the calculation of pressure of this trapped gas. Okay, first of all, let's talk about this. How we can calculate the pressure of this gas. But we know here we have used mercury. Now, again we choose one level. Okay, this level we have chosen. Pressure on this point and pressure on this point, they should be equal because they are at one unique level, one specific level. Then how do we calculate? Pressure on this point is P0, okay, P0 equal to pressure on this point is pressure of this liquid plus pressure of this gas. This gas also applied pressure here. So total pressure on this point will be P of liquid, pressure of this liquid plus pressure of gas, pressure of liquid plus H. H here means this height of this mercury. Okay, here again we have to choose one specific level and calculate pressure on that level. Okay. Here on point A we have only one pressure, that is gas pressure. So gas pressure is equal to pressure on this point. Here we have two different pressures. One pressure of this liquid, next pressure of this air. Pressure of air plus pressure of this height. Now let's solve some examples related to this topic. First example here. Calculate the pressure of the gas in the containers. Okay, if air pressure is 76 centimeter. Air pressure is given 76 centimeter, it means we are talking about sea level. Okay. Here, air pressure is 76, we have to calculate the pressure of this gas. We have to choose one specific level. Let's choose this level. And on this level, pressure will be same, both sides. And this one is also mercury. It is mercury. Okay, let's calculate pressure. Pressure on this point, only gas pressure. So, pressure of gas is equal to pressure on this point. Pressure on this point, here we have P0. So, P0 plus pressure of this liquid. Here liquid is mercury, 40 centimeter Hg. Air pressure is given 76 centimeter mercury. So P gas is equal to 76 centimeter mercury plus 40 centimeter mercury. Finally, 76 plus 40 is 116. P gas, let me write here. P gas is equal to 116 centimeter Hg. Let's solve this example. B. We have to calculate pressure of this gas. Again, we have to choose one level. This level we have chosen. This is open to air, then here we have only air pressure. P0. And here we have pressure of this gas plus pressure of this liquid. So P gas plus this example B, P gas plus pressure of liquid is 20 centimeter Hg equal to P0. Here we have only air pressure, P0. P gas plus 20 centimeter Hg is equal to 76 centimeter Hg. And here we have to take known values one side, variables one side. Only P gas is variable, so it is left side, and known values to other side. Now, here it is plus. If we take it into right side, then it will be minus. Then P gas is equal to 76 minus 20, it is 56. Okay, these are the results of these two examples. The pressure of gas Y. Where is gas Y? Okay. Pressure of gas Y is given 100 centimeter Hg. And we have to calculate pressure of Px. Pressure of X we have to calculate here. So again we have to choose one level. Let's choose this level. Then pressure on this level, pressure on this level and this level, they will be same, equal. On this level we have two pressure of liquid plus pressure of gas. So Px plus this height will be 10. Total is 5. This much we have separated, then it is 10. Centimeter. G is equal to pressure on this point. On this point, we have only this gas, pressure of this gas. It means Py. So Px we do not know, will be equal to minus 10 centimeter G plus Py is given 100 centimeter G. 100 centimeter G. So Px is equal to minus 10 plus 100 plus 90. 90 centimeter Hg is the pressure of this triple gas. Thank you so much. It is enough for today. In the next class, we will continue from Archimedes' principle and buoyancy.